Okay, let's start. Today we will talk about the two sample test. Okay, so the question is, first we have the control group, and we have data S1 to Sn. They all follow normal distribution. And we also have the treatment group. We have Y1 to Ym, and this is their distribution. And the goal is we want to compare the mean of the control group and the treatment group. Okay. So the first question is, what is the variance of S bar minus Y bar? So this is easy. So it's the content in the first exam. This is equal to variance of S bar plus variance of Y bar. The reason is because S I are independent to X, Y. And the variance of S bar is N sigma X squared Y squared. This is N. Okay. So this is the variance. And in B we want to find find how to estimate the variance of a previous question. So how to estimate this? And we have the additional condition is the variance are the same. So we can let the sigma square equal to this square. And so the variance of S bar minus Y bar is equal to sigma square. So now we only have to estimate the sigma square. So sigma square. Okay. The way to estimate square is we can use the poor standard deviation. This is definition is summation of Si minus S bar square plus summation of Yi minus Y bar square divided by N plus M minus 2. Okay. So you can prove that this is a consistent estimate for consistent estimate for sigma. Okay. So we use the poor standard deviation to estimate sigma square. So in the end, we will have the is equal to SP square times the constant. Okay. Okay, in C, okay, we want to find the we want to run a test with alpha equal to 0.05. And the test is look at this. So it's a one-sided test. So we can change the this is equal to mu x minus mu y equal to 0. Alternative is mu x minus mu y is greater than 0. Okay. So first we define what is our test statistic. In this case, why we use this one? So okay, consider test statistic T equal to S bar minus Y bar divided by the SP times square root of the okay. So the denominator is the estimate of variance S bar minus y bar. That's square root. And this statistics we know is distribution. Is the t distribution with a degree of freedom n plus n minus 2. This is under rule. Okay. The reason we want to use this as our test statistic is because we know its distribution. Okay. If we know the distribution, then we will be able to find the regression region. So, and because the alternative is greater than 0, it's greater than 0. So we will reject when the test statistic is large. So reject if t is large. Okay, and we know the distribution is t distribution. So we will reject when the test statistic is greater than t and alpha. Okay, this quantity is the 1 minus alpha quantile for this t distribution. So that means, so this is like this. This t. The tail probability, the right hand side probability is alpha, and this is our cost point, which is Tn plus n minus 2 alpha. Okay. So if the test statistic is greater than this, then we will reject the rule. Okay. Okay. Yes. So if the significant level is 0.05, then you can say we want to reject okay. It's D. Okay, let's do D. In D, we want to find a power if the mu s equal to mu y plus 1. Okay. So the mu s equal to mu y plus 1. That means mu x minus mu y equal to 1. So the t minus 1 will follow t distribution with n plus n minus 2 under the mu x minus mu y. 1. And we want to find a power. The power is equal to the probability of we reject. So we reject is alpha under the alternative, which is this. And we know we have this, so what we have to do is we minus 1 on both sides. And because this follow the t distribution, so we will have this. Okay. So this is power. So if you want to draw a graph, you'll be look at this. So here is alpha. Here the right hand have is alpha. And this the cost point is Tn plus m minus 2 alpha. And we move a little bit. Sorry, I think I did something wrong. Sorry. Okay. The t is equal to, T is equal to S bar minus Y bar divided by SP. Okay. And so we will have the T minus this. Follow the T distribution under the alternative. Okay. So what we want to do is a little bit different. So it's the same here. We want to find the probability we reject. So it's Tn plus n minus 2 alpha. And under the rule, under the alternative, so this is equal. Okay. Yeah. So we must minus this term. Okay. And we know this is a follow the T distribution. So this is T n plus n minus 2 greater than this. And the right hand side is the long number. So we will be able to calculate the probability. Okay, so now we can draw a graph. It's similar. The right tail probability is alpha. The cut point is a Tn plus n minus 2 alpha. And now we minus a little bit. So this is SPE. Okay. So the whole thing here is a power. Okay. So that's question D. Question E. Okay. The question is we want to do previous 3 questions again with the extra assumption that the values are all equal to 1. Okay. So that means in this case the values is known. When the value is known, we will use a normal distribution. So we can use the normal test, D test. If B is how we estimate the variance of y bar minus x bar. So in this case, we don't need to estimate because this is equal to this is equal 1 over n plus 1 over n. Okay. So we will say I will use 1 over n plus 1 over n to estimate variance of S bar, Y bar. And in part C, we want to run a test. So in this case, I will use the statistic like the observed is equal to S bar minus Y bar divided by the variance. Okay. And this will follow the normal distribution with mean 0 and variance 1. Yes. So the rejection region will be the observed greater than the z alpha. Okay. So it's same. So we reject where the value is large, and we find the cut point of the 1 minus alpha quantile. This is a z alpha. At D, we want to find a power. So the power is so in this case we will have the D observed minus 1 divided by this. It's follow normal distribution under the rule. So mu x minus mu y equal to 1. So the probability we reject, the power is the probability we reject. So the power is equal to the observed greater than z alpha condition on the alternative. So 1. Okay, and this can be what? So we do the same thing minus this. And this is equal to probability of z greater than alpha. Standard normal greater than z alpha. Okay, so this is D. Okay, so when the variance is unknown, you have to use a T distribution. And when the variance is known, you have to use the normal distribution.